Okay guys, this is number 3 on the Regents Review videos. I'm going to go through it. I know this is the third one that we've done with graphing inequalities. If you think you have it, just fast forward to the end and see if your picture looks like mine. We've got two equations. It says graph on the set of axes below, graph the following system of inequalities. You want to get each of these inequalities set equal to y, so it's in y equals mx plus b form. In this case, the first one, y plus x is greater than or equal to 3. You want to subtract the x, and you will end up with y is greater than or equal to negative x plus 3, giving you a slope of negative 1 over 1 and a y-intercept of 3. Remember, before we start, we should remember that we have shading in this picture, and we have a solid line because there's an equal to, a dotted line because there is no equal to under that inequality. So the first one, we're going to start at 3. 1, 2, 3. We're going to move down 1 to the right 1, down 1 to the right 1. Don't forget about your ruler. Let's make this a solid line. Make sure it goes through the points and it extends through the entire piece of graph paper. Arrows on the end. We want to look at that point 0, 0, put it into the original inequality, which is 0 plus 0 greater than or equal to 3. 0 is greater than or equal to 3 is a false statement. Therefore, we do not shade where 0, 0 is. We shade on the other side. We want to shade the entire side of that line that is going to give us all the points that make our inequality true. Then we have 5x minus 2y is greater than 10. This one takes a little bit more work to get y by itself. We want to subtract 5x. Negative 2y is greater than negative 5x plus 10. I like to put that x term first so that we are in y equals mx plus b. Divide by a negative 2. Now this time when I divide by a negative with any inequality, I need to remember to flip the inequality. A negative over a negative will give us a positive 5 over 2x. 10 over negative 2 gives us a negative 5. So therefore the slope on this line is 5 over 2. The y-intercept is negative 5. We're going to begin at negative 5. 1, 2, 3, 4, 5. And to get to our next points, we're going to move up 5. 1, 2, 3, 4, 5. To the right 2. 1, 2, 3, 4, 5. To the right 2. And remember that this is just a greater than, so it's going to be a dotted line. Again, making sure that it goes the entire length of that graph. Again, we're going to pick the point 0, 0. 5 times 0 minus 2 times 0 is greater than 10. 0 is greater than 10. Is that a true or a false statement? It is false. Therefore, we do not shade where 0, 0 is because it is not a member of my solution set. So we're going to shade on the other side of the line. And we want to label the solution with our big fat S. And that is always right where my shadings overlap, which would be right in here. Let's go back to the question and see if there's anything else we need to do to answer it. State the coordinates of one point that satisfies y plus x is greater than 3, but does not satisfy 5x minus 2y is greater than 10. So we want to find a point that's in this shading, but not in that. So if I look at the line that's a solid line, that's this one, the shading goes over here, so I can pick any point that is in the black shading only. So I'm going to pick the point 0, 6. 0, 6 is in the solution set for the first inequality, but not in the second. Okay, hope you did all right with that one. We're going to be moving on. Wait for the next video for number 4.